Today we are going to learn about the methods for adjustment of tonicity. Here I am going to deal with the creation of the equation. Many people have difficulty in understanding these methods. What I am going to do today is I am going to create the equations. I am going to tell you the concept behind each method, how that equation came and what is that concept for each method, so that it will be easy for you to remember and to solve the problems. So we will try to see that. So before starting, what is tonicity? Tonicity, if I am saying any solution is isotonic with the blood, it means the osmotic pressure of that solution and blood is same. That type of solution we call it as isotonic. So the osmotic pressure of that particular solution is same as that of your blood. We call it as isotonic solution. Now we have formulations like injections, IV dosage forms, etc., where we are injecting the drug directly into the bloodstream. Now if the solution is hypertonic or hypotonic, it will cause irritation and problems in the blood. So we don't want that to happen. Hence we convert the given injection solution to isotonic solution. So what are the methods? So the methods are of majorly two types. First method is addition of NaCl, or you can say addition of tonicity adjusting material, that is your NaCl. So addition of tonicity adjusting material. What do you mean by this is, you will be given already with the drug solution. Into this drug solution you need to add tonicity adjusting solution, that is NaCl. So how much amount of NaCl need to be added? That is your first method. Second method is addition of previously adjusted solution. So what do you mean by this previously adjusted solution is, I will be given, see here in this first method I have given you drug solution. In the second method I will give only drug powder. The drug powder is given, the amount of drug is given. So first you need to add water. You need to add some amount of water such that this X amount of drug which is given in the beaker along with this added water will become isotonic. Means what? We are converting the drug by the addition of water. Whatever the water you are adding, whatever the drug solution you are going to form after adding the water, that solution should be isotonic by itself. Okay. So after adding water, let's say this is the amount which of water I have added. Let's say you are asked to prepare 30 ml. So if I added 10 ml only, it became isotonic. Only with the plain drug, 10 ml of water became isotonic. The remaining 20 ml, because I asked you to prepare, total is 30 ml. The remaining 20 ml is, we are adding previously adjusted isotonic solution. Means what? 0.9% NaCl. So you know already that 0.9% NaCl is isotonic solution. So you are adding the previously adjusted isotonic solution. What? How much? 20 ml. Okay, that what is the two methods. Regarding this method I will teach you in detail in the coming part of this lecture. Now we will try to see the first method. So we will try to see the first method, that is addition of NaCl. Or you can say addition of NaCl is a tonicity adjusting agent. We can call it as addition of tonicity adjusting agent. This is divided into two types. So we are adding NaCl, it is a tonicity adjusting agent. Again, there are two methods which will calculate how much amount of NaCl is to be added. So your first method is freeze point depression method. Freeze point depression method, and the second method is NaCl equivalent NaCl equivalent method. So we have two methods, freeze point depression method and NaCl equivalent method. Now freeze point depression method, we try to see this method, first one. So what it says, freeze point depression, we says the name says freeze point depression. So the freezing point is going to depress. We have some limits for the freezing point. For example, you take plain water. This plain water is going to freeze at 0 degrees centigrade. This is the freezing point of the plain water. Now, if I add anything in the plain water, this added thing will decrease the freeze point. That what is freeze point depression. For example, if I add 0.9% of NaCl, 0.9 grams of NaCl in water, then if you try to freeze the 0.9% NaCl solution, it is going to freeze at minus 0.52 degrees centigrade. Now see the difference. Plain water is going to freeze at 0 degrees centigrade and your 0.9% NaCl solution is going to freeze at 0.52 degrees centigrade. Means what? From 0 to minus 0.52 is the depression of the freeze point of your plain water due to addition of 0.9 grams of NaCl in 100 ml of water. Next, if I add 1% of NaCl, again the freeze point will decrease, that is 0.58 degrees centigrade. So this is the concept behind the freeze point depression. Now what we have to do is we need to find out the equation for the how much amount of drug should be added for the freeze point depression. So what you have been given with is, you have been given with the beaker. In the beaker you already have a solution of drug solution. So you need to convert this drug solution to isotonic. So what is the isotonic solution's freeze point depression or freezing point of isotonic solution is this one. The freezing point of isotonic solution is minus 0.52 degrees centigrade. So I will write change in temperature of freeze point of your isotonic solution is equal to isotonic solution, I will write iso. So freeze point depression of isotonic solution is equal to what? You already been given with the drug solution. So drug freeze point plus NaCl freeze point. So drug freeze point depression, change in temperature of drug solution plus change in the temperature of amount of NaCl to be added. You need to understand this equation clearly. What is this equation is? Already I have a drug solution, in that I need to add some amount of NaCl. That's what the method is. Okay, freeze point depression. So the first method is addition of NaCl, in that it is freeze point depression. You are already given with the drug solution, you need to add some NaCl to the drug solution. After adding the NaCl, what is the resultant freeze point is your isotonic, that is 0.52. So your resultant freeze point should be, I want the drug solution should be isotonic 0.52 is equal to, we need to find out what is the freeze point depression of the drug. If the drug is present, if say 1 gram of drug is present in this, or 0.5 grams of drug is present, due to that present of 0.5 gram of drug in the solution, what is the freeze point depressed? Some freezing point will be depressed. What is the depression? Plus what is the amount of NaCl to be added to add more depression, to get the depression to 52. What I am trying to say is, initially you will begin with a drug solution with a freeze point depression of 0.12. You want 0.52 as a freeze point depression. So to get 0.52, how much amount of NaCl should be added? That what is this method? We try to create the equation for this. Now see here, freeze point is, how they will calculate freeze point is, if I add 1% of drug, what is the freeze point depression? Let's say D is the freeze point depression of the drug. Okay, it is the temperature. Okay, D is the temperature of freeze point depression. If I add X amount of drug, how much freeze point is the depressed? What I am trying to say is, initially scientist doesn't know what is the freeze point depression. What they will do is, they will take 1% of drug. This is the standard method of calculation. They will take 1% and they will calculate what is the freeze point depression. We don't have 1% drug here. We have some X percent. So I am writing what is the freeze point depressed for X percent. So if you do this calculation, you will get X into D. Assume this as a small d. That both terms assume as a small d. I will write like this. D indicates drug. Okay. Plus, again 1% of NaCl has a freezing point depression of how much? I already taught you 1% of NaCl has a freezing point depression of 0.58. We don't know how much NaCl we need to add. Assume it has a W amount of NaCl is added. That's what we need to calculate. So W amount of NaCl has how much freezing point depression? What is that? Cross multiply it, you will get W into 0.58 divided by 1. So substitute that. So this part is this one. So W multiplied by 0.58. You need to calculate W here. Rearrange the equation, send this D here, you will get 0.52 minus D divided by, after sending the D here, you will be remain with the plain W into 0.58. Send this 0.58 this side, you will get 0.58 here is equal to W. This is the equation. So what we just did is we created the equation for the freeze point depression. Now in the calculation part, they will give you the freeze point depression of drug. They will give the freeze point depression of 1% of drug. You need to calculate the freeze point depression for X amount. How you will calculate? By this cross multiplication. Whatever the amount is there, multiply that amount of drug with the freeze point depression point of the drug, then you will get the freeze point depression of that amount of drug. That's what you have to keep here, D, not the direct freeze point depression given in the solution. You need to keep the freeze point depression for the drug, okay, which is given in for the X amount of the drug. That's what you need to keep, the freeze point depression. X amount of drug, they will be given freeze point depression of 1% of drug, convert that into X percent, that value you have to keep here. If you keep that value over, you directly get how much amount of NaCl to be added to get that freeze point depression. How much is the freeze point depression? That is isotonic 0.52 degrees centigrade. This is the freeze point depression for that given solution. Yeah, now we are going to see the second method, NaCl equivalent method. The name says how much amount of drug is equivalent to amount of NaCl. Means what? If you take, we will try to write like this, 1% of drug is equivalent to how much amount of NaCl. Means what? If you are given with this drug solution, if I can calculate what is the amount of drug present in that and which is equivalent to amount of NaCl, then I will come to know how much amount of extra NaCl I need to add. That's all. Already due to presence of drug, already there is some tonicity which is going to deliver by the NaCl. Due to presence of drug itself, there is tonicity which is going to impart for the solution. Apart from that, how much amount of NaCl I need to add, that I need to calculate. How much amount I have to add. For that we have a equation, we need to calculate that. So the total amount of NaCl to be added to get isotonic solution is 0.9 gram in 100 ml. Due to presence of drug, how much NaCl is present, that we need to calculate. So for that, 1 gram of drug is equivalent to X amount of NaCl. I will write as equivalent. 1% of drug is equivalent to some X amount of drug, or you can say 1 gram of drug is equivalent to some X amount of NaCl. So Y amount of drug is equivalent to how much amount of NaCl. So if you calculate this, or you can say W amount of drug is equivalent to how much amount of NaCl. So what is the conversion factor here is 1 gram of drug is equivalent to some X amount of NaCl, that we call it as equivalent weight. W grams of drug is equivalent to how much amount of NaCl? One is this much. W is how much? Cross multiply this. That you will get W into equivalent factor. W into equivalent weight of the NaCl. So this means what? Due to presence of W grams of drug, this amount of NaCl is already present in the solution. How much we want? Total is 0.9 minus what is present, that is W into equivalent. This gives you the amount of NaCl to be extra added into the solution to make that solution isotonic. That's how we create the equation. So it will give the amount of NaCl. This equation will give the amount of NaCl. Total we want 0.9 only in 100 grams. For I am talking about the 100 ml. Okay, for 100 ml this much amount. 0.9 is there. Minus what is the equivalent of NaCl present due to presence of that amount of drug in the solution. So that equivalent is this one. This is the conversion factor. So what this factor will tell you about is due to presence of that amount of drug which is equivalent to how much amount of NaCl for that amount of drug. That was the conversion factor. So total is 0.9, present is this much. If you negative it, you will get how much to be added. That what the equation is going to tell you about. This is what about your NaCl equivalent method. Yeah, now we are going to say about addition of previously adjusted solution. Second method, previously adjusted. First method we added NaCl. For that we try to calculate the amount of NaCl should be added in the two methods. In the second method we are going to add previously adjusted NaCl solution. For that we try to see here. What this method is saying is, let's say I will be giving, I will give some amount of drug is present in the solution. I will give this amount of drug is present in the solution. We don't know that. Assume that is X grams. Already X grams of drug is present in the solution. Okay. So in the NaCl equivalent, I told you due to presence of that X gram of drug, which is equivalent to some amount of NaCl. So if I want to make only this X gram of drug isotonic, let's say I will ask you to prepare 30 ml of drug solution. Okay. So the method of preparation with this method is, we call this method as White-Vincent method, name of the scientist who invented this method. Okay, so the method of preparation through White-Vincent method is, you will be given is some X grams of drug. First you need to add water. Here the whole calculation will revolve around, you need to calculate what is the ml of water to be added to make the X gram of drug isotonic. That was the full calculation in this method. So how much amount of water I need to add to make this X gram isotonic? Let's say I need to add, after calculation, let's say you found 10 ml to be added as a 10 ml of water to be added for the X gram of drug to convert into isotonic. So if you add 10 ml, this X amount of drug will be converted as such into isotonic without need of NaCl. Rest, I ask you to prepare 30 ml, not 10 ml. So rest 20 ml should be what you have to add. If you add plain water for the rest 20 ml, that isotonic solution will become hypotonic solution. To avoid that, what we will do is, we will add previously adjusted isotonic solution in that. So we are going to add the previously adjusted isotonic solution, that is 0.9% NaCl solution. You need to add the 20 ml. So total become 30 ml. This is the method how you are going to calculate. So the whole method revolves around calculation of how much amount of water to be added. For that, first we need to know what is the equivalent. See, what we know is, for 0.9 grams in 100 ml gives you isotonic. If I add 0.9 grams of NaCl in 100 ml gives you isotonic. Now I need to calculate this X amount of drug, due to presence of this X amount of drug, which is equal to some equivalent of NaCl. We need to convert. First method is convert your X amount, X grams of drug into NaCl equivalent. So you need to convert that. We know what is the equivalent factor. I taught you in the previous method. Directly you need to add X amount of drug multiplied by equivalent of NaCl. It will be given. The equivalent 1% of drug is equivalent to some amount of NaCl. So X amount is equivalent to how much? You need to calculate this. See, 1% of drug is equivalent to NaCl. X amount is how much? X into equivalent. That's what I am writing here. So this is the factor for the conversion of drug grams into NaCl grams. So you are directly converting drug into NaCl here. Okay, that is the factor. Now, so this is, assume this has Y. So Y grams of NaCl is present with us here. Actually we don't have NaCl here, we have drug here. We converted drug into equivalent NaCl. We got that as Y grams of NaCl. Now 0.9 gram of NaCl in 100 ml gives isotonic. Y gram, for Y gram how much ml of water I need to add? Cross multiply this, you will get Y into 100 divided by 0.9. If you solve this thing, you will get Y into 111.11. So whatever this factor is there, substitute here. What is Y? I told you. Y means what here? Y is X into equivalent. So I will write X into equivalent multiplied by what? 111.11. Gives you ml of water to be added. That will give you ml of water to be added. So how you need to solve the question? X means amount of drug present in the given solution. They won't give the amount as grams. They may be asked, we have 1% of solution, we have 2% of solution. 1% 30 ml. You need to calculate how much amount of drug is present. 1% 100 ml means 1 gram. For 30 ml, how much? You need to calculate that one. So you need to calculate the amount of drug present. Equivalent factor is already given in the equation or in the problem, and this is the conversion factor, that is 111.11. This will give you ml of water to be added. So here you will get some ml. That ml is this 10 ml. I told you add 10 ml. So if you add 10 ml of water to this drug, it will become isotonic by itself without addition of NaCl. The rest, whatever the preparation is asking, you need to add previously adjusted isotonic solution. Question, sir, why we are adding previously adjusted isotonic solution? Reason is, if you add plain water to this, it is already adjusted solution. If you add plain water, see here, this one we have adjusted by adding 10 ml of water. It is isotonic. If you add plain water, it will become hypotonic. Hence, everything will be gone. We want to add the rest. Makeup of the volume will be done by previously adjusted solution. That is 0.9% NaCl solution you have to add and make up to the volume. So this was the concept for the tonicity adjustment. The calculation part of this I will try to take in the next video. Thank you.